Welcome to this explainer. Okay, I want you to picture something with me. Imagine we're stepping into this lush, beautifully hand-drawn world with giant ancient trees and sprawling clouds right above us. We're tagging along with a super curious 11-year-old explorer named Deepa and her guide, Maestro Metre. He's this gentle, incredibly intricate clockwork automaton. Together, they're on a quest to map the mysterious Whispering Woods. But here's the catch. To map a forest, you first have to know how to measure it, right? And as we're going to see right off the bat, measuring the universe is actually way more magical and precise than you might think. So imagine Deepa finds this ancient, smooth stone table in a clearing, and she wants to know how long it is. She uses her handspan, stretching from her thumb to her pinky, and carefully walks it across the stone. She counts exactly 13 handspans. But then Maestro Metre steps up. He uses his huge brass mechanical hand to measure that exact same table. Because his hands are so much bigger, he only counts 5 handspans. Now, the table hasn't changed size, right? Yet they get 2 totally different measurements. Why? Well, because no 2 hands are exactly the same size. And honestly, this brings up a huge realization for Deepa. Using body parts like handspans, arm lengths, or even counting our strides when we walk, it's just a super unreliable way to measure things. Think about it. If tailors and builders relied entirely on the sizes of different people's feet or fingers, literally nothing would ever fit properly. A door bit by a giant definitely wouldn't work for a child. So to really understand and share the dimensions of our world, we absolutely need a common language. This exact problem has actually echoed throughout human history. For centuries, people did exactly what Deepa did. They used ancient body units. Like in India, for example, people used the angula, which is just the width of a single finger, to measure architecture and artifacts. But as people started traveling and trading across the globe, this created, a massive amount of confusion. The world needed a universal system that never changes, whether you're in a bustling modern city or out in the quiet Whispering Woods. We had to move away from body parts to a globally agreed-upon language of measurement. To solve this whole mess, humanity created the International System of Units, or SI units for short. It's the ultimate standard. And the foundational SI unit of length, that's the meter. Imagine Maestro Metre's brass gears just clicking softly as a small hatch on his chest opens up, revealing a perfectly straight standard 15-centimeter scale for Deepa. This scale doesn't grow, it doesn't shrink, and it definitely doesn't change depending on who's holding it. It is absolute. Figuring out how these standard units relate to one another is almost like reading an ancient magical codex. It breaks down how we measure the vastness of the world all the way down to its tiniest details. So, to measure a really long journey across the forest, you'd use a kilometer, which is 1,000 meters. For the height of a tree, you'd just use meters. And 1 meter holds 100 centimeters inside it. But what if you want to measure the delicate thickness of a fallen autumn leaf? Well, then you dive even deeper, right down into millimeters. Actually, think about the number 10 for a second. There is this tiny hidden world inside our standard measurements, completely governed by it. If you look really, really closely at the 15-centimeter scale the Maestro handed Deepa, you'll see that between every single centimeter mark, there are exactly 10 smaller spaces. The length of one of those incredibly tiny parts is a millimeter. 10 millimeters make up 1 centimeter, and that is the absolute smallest value you can read on Deepa's scale, which lets her be incredibly precise when mapping all those tiny wonders in the forest. But having a standard scale is really only half the magic. Knowing how to actually use it, that's the real secret. Maestro gently points out to Deepa that you have to master the technique of precision. See, if you look at the scale from an angle, maybe from the left or the right, your eyes will literally play a trick on you. It creates this optical illusion and you're going to read the wrong number. To find the true measurement, your eye has to hover directly, perfectly above the tip of whatever object you're measuring. Okay, but what happens if an explorer's tools get damaged out in the wild? Like, what if the 0 mark on your scale is completely chipped or broken off? You don't just throw the scale away. Maestro Metre shows Deepa this brilliant little mathematical trick. You simply start measuring from a clearly visible full mark, let's say the 1.0 centimeter line. You lay the object down, note exactly where it ends, and then you just subtract that starting 1.0 from your final number. So if a shimmering blue feather ends at 10.4 centimeters, but you started measuring at 1.0, its true length is 9.4 centimeters. It is such a wonderfully simple problem-solving tool. But nature isn't really made of straight lines, is it? As Deepa looks around, she sees twisting vines and winding riverbeds. and you obviously can't bend a stiff ruler around a tree trunk. So Maestrometer pulls out a glowing silver spool of thread. To measure a curve, you just wrap the flexible thread perfectly along the path of that curve. Then you pinch the endpoints, straighten the thread out completely flat, and measure that straightened thread against your straight scale. Just like that, those impossible-to-measure shapes of the natural world are totally unlocked. Okay, I want you to think about something for a second. Are you moving right now, or are you at rest? It seems like an incredibly simple question with a totally obvious answer, right? But the universe is a bit more beautifully complicated than that. This question is actually going to completely shift our perspective. Picture this. Deepa and the Maestro are sitting on this massive, emerald green lily pad. The rushing, roaring water of the river is carrying them downstream at tremendous speed. Yet as Deepa sits there on the leaf, hands folded in her lap, she feels perfectly calm. She looks at Maestro Metre sitting right across from her, and between the two of them, the distance isn't changing at all. And this brings us to a real moment of awe. The secret of the universe here is something called a reference point. A reference point is just a fixed object you choose to compare yourself against. To a bird flying way up in the sky, looking down at the river, Deepa is moving super fast through the forest. But if Deepa uses the lily pad, or even Maestro Mitre, as her reference point, she is perfectly still. Motion is entirely relative. It depends 100% on what you choose as your anchor. So this brilliantly illustrates the difference between being at rest and being in motion. It's kind of an illusion, really, like a beautiful dance. An object is in motion only if its position changes over time relative to its reference point. If the distance in direction between you and your reference point stay exactly the same, you are at rest. This entire bustling, spinning universe can be simplified just by choosing where to plant your flag and observe.
Now, as Deepa and Maestro step off that lily pad, a gentle wind sweeps through the whispering woods, and the whole forest just comes alive with movement. Maestro explains that all this chaotic, beautiful motion can actually be categorized into 3 distinct synchronized dances. So let's take a look at the 3 types of motion happening all around us: linear, circular, and oscillatory.
First up, we have linear motion. And this is pretty much exactly what it sounds like, an object moving along a perfectly straight-line path. Deepa looks up into the towering forest canopy, and a single bright orange breaks loose from a high branch. It plummets directly down in a straight, uncompromising line right to the soft moss below. That falling orange, or say a heavy box being pushed straight across a floor, that is experiencing linear motion. Next up is the second dance, circular motion. As they walk, Deepa spots an ancient stone ruin, and sitting right on top of it is this delicate wooden wind catcher. The breeze catches its scoops, and it starts spinning round and round, tracing a perfect circle in the air. Its distance from the center never actually changes, kind of like a child spinning happily on a merry-go-round. When an object moves along a circular path like that, it's captured in the grace of circular motion. Finally, we have oscillatory motion. Deepa sees a heavy, smooth stone tied to a thick, hanging vine. The wind pushes it gently, and it starts to swing. It moves forward, pauses, swings backward past its center, pauses again, and swings forward. To and fro, back and forth, but it's always anchored to that fixed branch up above. Whenever an object continuously moves back and forth about a fixed central position, just like a pendulum in a grandfather clock or a kid on a playground swing, that right there is oscillatory motion. Now, there is a magical rhythm that connects both that spinning wind catcher and the swinging vine. Maestro Metre calls this periodic motion. It's motion that repeats its exact path after a fixed interval of time. The wind catcher completes a circle every few seconds. The stone swings back to its starting point over and over in this perfect exact rhythm. The forest isn't just moving randomly, it is keeping a heartbeat, it's keeping time. So, what should we really take away from Deepa's journey through the Whispering Woods? Well, the universe is constantly alive, constantly breathing, and constantly in motion. But by using standard units of measurement, like the super precise meter, and by understanding reference points, we actually have the power to make sense of it all. We can measure the curve of a leaf, track the speed of a rushing river, and understand the beautiful swinging pendulum of nature. Measurement isn't just boring numbers on a page, it's literally the key to unlocking how reality works. And I want to leave you with one final kind of awe-inspiring thought. Think of yourself sitting exactly where you are right now, maybe at your desk or chilling on the couch. Compared to the room around you, you are perfectly at rest. But If you change your reference point and compare yourself to the massive, burning sun millions of miles away, what kind of motion are you really in right now? Think about the spinning Earth beneath you, tracing its path through space. You are actually moving faster than you could ever imagine. Thanks for exploring the wonders of measurement and motion with us. Keep observing, keep questioning, and keep looking at your world with wonder.